Hello friends, welcome to Susan and John MathTube. In this video, we are going to derive the equation of tangent to the standard ellipse. Okay, and remember the point of tangency will be given in the question. Okay, so I hope you remember the standard ellipse. Standard ellipse means the ellipse which will have the major axis as the x-axis and the center will be the origin. Okay, it kind of looks like this. And second thing, the equation of standard ellipse which we derived and which is very important, the derivation is also very important, is x square by a square plus y square by b square equal to 1, where a is supposed to be greater than b. This is supposed to be the standard ellipse. Okay, and in today's lesson, what we do is we learn to derive the equation of tangent if the point of tangency is given. So look at this. Here the point of tangency means it will be a point on the curve, the point on the ellipse where you draw the tangent. So remember, point of tangency is that point which the tangent will touch the curve. So let's assume that point is x1, y1. Okay, now one very important question. You are watching a video lesson. Are you ready with pen and paper? Yeah, that is very important to make the video lesson efficient and effective. So I will give you what to write, the description. But you listen to that and make your own description so that you don't have to depend on a textbook or the words that I tell you or some other means. Okay, you can make your own derivation. So let's start. You write like this. Consider the standard ellipse x square by a square plus y square by b square equal to 1, a greater than b. And then you can draw the standard ellipse. So tell me what's special about the standard ellipse? Yeah, the center will be the origin and the axis will be along the major axis will be along the x-axis. Now what is given in the question? Yeah, the point of tangency, the point of touch. Do you remember? Tangent means it is a line. What is a tangent? A line which will touch the curve. So the point of touch, the point of tangency, we assume that point to be x1, y1. So I hope you understood the description, the equation, the point of touch, and we remembered the tangent is a line. Okay, now look at this. This is what we want. Now you can draw another picture, an ellipse. It's a standard ellipse. I'm not drawing the x-axis, y-axis. Now what I do is I will draw the point of touch, our x1, y1. Now what you do is you're going to call it A. Now what you do is you take another point B, x2, y2. So what did you do? You write like this. Let B, x2, y2 be any point on the ellipse. So we take another point. Now I want you to take a look at this. What do you call this? Do you remember the name? Yeah, it's a chord. What do you call this? It is called a chord. Chord or second line. So please write, let A be the point of tangency and B be any point on the ellipse. And consider the chord passing through A and B. Okay, now look at this. The logic of the proof lies in a trick. And the trick is the connection between a chord and a tangent. Once you understand the connection between a chord and a tangent, you will be able to derive by yourself. So look at this. I'll show you the trick. So I took B here, but some other might take B here. Another person might take B here. Someone else might take B here. Someone else might take B here. Some people might take B nearby A. Some people might take B very near to A. Now I'll show you something with the help of a vector. So look at this. This is a chord. If B is here, this is the chord. If B is here, this is the chord. And if B is here, this is the chord. By the way, if B is very nearby, see? Oh, the chord becomes a tangent. The nearer you go towards A, when you take the point B, very near to A, you can see yourself. The chord becomes a tangent. So I'll show that once more. So right now, this is our chord. Can you see the chord? AB. Okay, what I was telling you is, or what I was suggesting is, if you take B nearer and 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 nearer, the chord jumps outside and it becomes a tangent. You can observe yourself. The nearer to A, it becomes a perfect tangent. Okay, that's it. Once you understand this logic, there is nothing more to explain. You can even derive yourself. So the proof starts like this. We have the standard ellipse and we took 2 points. One is the point of tangency, the required point, and another is a point x2, y2. And what we learned is, when B tends to A, the chord AB becomes the tangent at A. I hope you understood that language. This is the logic behind the proof which we are going to do. Okay, let's start. So look at this. This is a point on the standard ellipse, right? This x1, y1, the point of tangency is a point on the ellipse. And this is also a point on the ellipse. Okay, so point on the ellipse will balance the equation of the ellipse. So I can easily write x1 by a square plus y1 by b square equal to 1. And as engineering students and bachelor students, I know you won't have any trouble in digesting these things. A point on a structure will satisfy its equation. Similarly, x2 square by a square plus y2 square by b square is equal to 1, because this x2, y2 also belongs to the ellipse. Now let's call this as equation 1 and call this as equation 2. And I'll tell you very clearly, what I am trying to find is the slope of this chord. What am I trying to find? The slope of this chord. Slope is given by y2 minus y1 by x2 minus x1. I'm sure you have learned this in your younger classes. Slope of a line passing through x1, y1 and x2, y2 is given by y2 minus y1 by x2 minus x1. And that is the reason I wrote this. I'm going to do equation 2 minus 1. What is my aim? My aim is to find the slope. And what is the slope? y2 minus y1 by x2 minus x1. And my intuition, my common sense tells me, if I subtract second minus first, I'll be able to find y2 minus y1 by x2 minus x1. So let's go for it. Subtract. So x2 square by a square minus x1 square by a square, so that a square comes common, plus y2 square by b square, same logic, minus y1 square, b square comes common, equal to 1 minus 1, 0. Okay, now tell me what is x2 square minus, x2 minus x1 into x2 plus x1. All of you know the formula, a square minus b square. Still, if there is someone who doesn't know the formula, please do note this. It might sound silly for someone, but for someone else it might be a treasure. Okay, so y2 minus y1, y2 plus y1 by b square is equal to 0. In the next line, what we do is we'll take it to the other side. So we get is equal to negative. By the way, what am I trying to find? The slope. And what is the slope? y2 minus y1 by x2 minus x1. And We can just do a little bit of cross multiplication here. So we get y2 minus y1 by x2 minus x1. I'll put those things in color. Yeah, this is what we want. And what I did is I just did cross multiplication. I just took it to this side. This will be equal to x2 plus x1 by a square times b square by y2 plus y1. And of course, who can forget that negative? And it is safe to put a bracket. Okay, so I hope you're 100% okay with this. So I'm going to write. Now look at this. I will show you this picture very clearly. This blue line is the chord. It is the chord passing through x1, y1 and x2, y2. And chord is the line. So the equation of the chord. So I'm going to write equation of chord AB is y minus y1 equal to slope. What's the slope? This is the slope. I just derived it. Minus b square by a square into x2 plus x1 by y2 plus y1 times x minus x1. I hope you remember the equation of a line passing through x1, y1 and x2, y2 is given by y minus y1 equal to slope times x minus x1. Anyway, we have the slope. Wait a minute. What did they ask and what did I derive? Think about it once more, please. We were trying to derive the equation of a tangent. And what did I do just now? I found the equation of a chord. Yeah, it's nothing to worry because they are connected. And what is the connection? Do you still remember the connection? A chord becomes the tangent. Look at this. The chord AB becomes the tangent. The chord AB becomes the tangent when B tends to A. So I'm going to write the same dialogue here. I'll repeat once more. They asked me find the equation of tangent. Finally, what did I derive? Equation of chord. Now I'm going to write a dialogue. Clearly, or we know that, you can write anything you want. The chord AB becomes the tangent at A x1 y1 if B tends to A. That is x2 y1, x2 y2 tends to x1 y1. That is x2 must tend to x1 and y2 must tend to y1. Okay, so that's it. So I'm going to use or misuse this equation. Just beneath it, I'm going to write equation of tangent at A x1 y1. Now look at this. This is the equation of chord AB. And I have written very clearly the chord AB will become a tangent if, tell me please, yeah, b square by a square. x2 must become x1. So x1 plus x1 will be 2x1. y2 must become y1. So y1 plus y1 is 2y1 times x minus x1. And this 2 and 2 will get cancelled. And now I'm going to take this y and b, because in ellipse I have noticed that x and a are friends and y and b are friends. So I'm going to use the same logic. So I'm going to write y1 by b square, y minus y1 is equal to minus x1 by a square, x minus x1. Now let's open the brackets. So y1 by b square minus y1 square by b square equal to minus x1 by a square plus x1 square by a square. Now I'll take you to the left side, right side, etc., etc. Our usual trick. x1 by a square plus y1 by b square equal to x1 square by a square plus y1 square by b square. Wait a minute, I have seen this guy somewhere. What is x1 square by a square plus y1 square by b square? Isn't it equal to 1? Yeah. So what we do is we plug in 1 here. So we get x1 by a square plus y1 by b square is equal to 1. That's it. That's it, my friends. The derivation was quite easy. I'll be back with more videos, and as always, if you like the video, please share, subscribe and like. So we'll meet soon. So till then, my friends, bye.